Hello, and welcome to 5-Minute Math. Today we are looking at the fifth grade concept of operations, specifically how we can represent operations that use fractions, and we'll do it in 5 minutes or less. So we have a number line here, and it is representing a subtraction operation. So let's see what we're looking at. First, we're going to start with 0. And you see we're going to move over to the right. So that's going to be our starting number, right? Our minuend. And let's see what we have here. We've got 1, 2, 3, 4, 5, 6 little marks, which means we're breaking this up into sixths, okay? And so this first one is 1, 2, 3, 4, 5. This starting location is going to be 5/6. And that's going to be our starting location, but you see we're going back to the left, which means if we're going back towards 0, we are going to subtract something. Now, I know what you're thinking. You're thinking, well, that's going to be easy. That's one that's 2/6. And if you said 2/6, you would not be incorrect. But most likely you would see this look a different way. So let's see how we can reimagine that 2/6. Because one thing we learn is that we can have equivalent fractions, right? There are two different fractions, sometimes 3, 4, an infinite number, that can represent the same distance on a number line. So what we did is we originally marked this up as sixths, but let's see if we can break this up into bigger chunks. I'm going to draw some big lines here. Take a look at this right here. So there's going to be one big chunk right there. I'm going to draw another big chunk right through where I put my 2/6. And I'm going to put a third chunk right here. So take a look. I just broke this up. Instead of sixths, there's 3 big chunks. And you notice that each of my big chunks are worth 2/6. So this is 1/3, this is 1/3, and this is 1/3. And each of these thirds are equal to 2/6. You notice so we can just double the numerator and the denominator. Okay, so let's take a look at what I am subtracting. I am subtracting 2/6, but look, it's jumping this line, but take a look. It's 2 chunks. So 2 chunks is 2/6, and we know that 2/6 is equal to 1/3. So another way to represent this would be 5/6 minus 1/3. Now, if we really want to subtract this, we can't subtract unless we have the same denominator. So it would be easy for us to do it if we went ahead and left it in that 2/6, because we'll see that we've got 1, 2, 3, 6 left. And hopefully you see, if you've got 3, 6 left, another way to envision this 3, 6, I'm going to draw an even bigger line. Look, that's halfway through. So there's a lot of ways we can make some fractions stay the same denominator. Some fractions have a smaller denominator, even a larger denominator, by looking to see which amounts have the same distance away from 0. So let's look at this example here. We have 2 kids, Carl and Fiona, and they're eating, let's say, a candy bar. Graham cracker, doesn't matter. They're eating out of the same type of candy bar or graham cracker, whatever the problem is. And Carl eats this amount up here. So let's put a little rectangle around that amount, and Fiona eats this amount. So the question might be, how much of that, let's say, candy bar, did they eat together? Well, we need to identify these fractions here. So let's look at Carl. Carl is this top row right here, and we need to notice that this top row is broken up into eighths. So Carl ate 2 out of 8 pieces. I'm going to put this right here, 2/8. Fiona had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. She ate smaller pieces, but more of them. And she ate, and you can see there's 7/12. So if we combine both of their pieces, really what we're looking for is we're looking to add these, right? 2/8 plus 7/12. Now, we can't add if we don't have the same denominator, just like we can't subtract if we don't have the same denominator. But take a look at this picture right here. It shows us an equivalence. It shows us that 2/8 is equal to, look at 1, 2, 3 twelfths, because you notice they go to the same distance there. And so I'm going to take these 2/8 and I'm just going to move them down here and count them as 1, 2, 3 twelfths. And we can see that total is going to be 10/12.